এটা খুব অ্যাক্টিভ হবে।
দেখুন কিছু আসছে
না।
কি
এবার আসবে।
আপনি আমি এক্ষুনি এসছি। Yes, thank you. I am much better. Yes, thank you for your query, Ovishikta. I am much better now. In fact, I am absolutely fine now. So, I guess I was off color for about I think 7 days. I think so, but I am absolutely fine now. So the thing is that today we are going to do indefinite integration. Uh, we have actually done integration quite a few times, um, in various stages of our class 12 studies. We had done it, way back in the month of April, and then perhaps we had done it again sometime in June, I'm not sure, or maybe July. So today I'll do one thing, since we have already done integration, I'll do one thing. I'll just make sure that we keep a slightly good standard of practice today. I don't want to, I don't want to do something which is very very easy. At the same time, it should be relevant and important for your school exams and board exams. So keeping that in mind, uh, well, the thing is, I'll tell you, there's a bit of a issue regarding this homework and tests and assignments. So first of all, I have noted your query, Abhishekta. You have raised a very relevant query that from where should we do the questions. What has happened in the last couple of months that many students have complained about the Teachment app, that they are facing some problem, various types of problems, network problem, video is suddenly going off, and assignments we are not able to submit, etc. So because of that, I'm trying to reduce the usage of Teachment. In fact, I haven't been using Teachment except for chemistry classes, and even that also I'm trying to change if possible. And the fact is that the assignments, if I have to give to all of you, I'll have to probably think of an alternative like Google Classroom. Maybe I can make a folder where I can give you the assignments. But I personally would recommend that since I have settled down to this mode of teaching on YouTube, like I have settled down to this, like I am now very, very comfortable with this. So I would like to take this opportunity to give you more inputs. I would say perhaps more than what I was giving you earlier. Like earlier, we used to have classes through screen sharing, but I realize now this is a better way of interaction. So I would like to give you more inputs and maybe do a few sums where some tricky concepts are involved, and maybe that will help you to try from any book of your choice. So that is my final answer to all of you, in fact, that you can do the practice from any book of your choice. Yes, you can do NCRT, you can do R.D. Sharma, M.L. Agarwal, these are the famous books. So I will not say one is better than the other, they are all equally good. But I think what I was more concerned about, one is though the problem with the Teachment app. So I have now consciously tried to reduce the usage of that app. The other is that as a teacher, can I give more inputs in the same session? So I realized that yes, I can if it is through YouTube. So yeah, you're welcome. I mean, you're always welcome, and it is a very good question you have asked because I haven't been giving any assignments for a long time. And just before your board exam of December, I was giving test papers on WhatsApp. Again, that is because of the fact that it wasn't clear how I should give the test papers. So I have more or less reconciled to two things now. One is that this mode of interaction is the best for me. I guess it is also the same for all of you. The second is that even if I don't give assignments, I will definitely take tests, that is for sure. And perhaps it is appropriate that I make a folder in the Google Classroom, which is a very universal kind of app. Everybody has access to it. So, and I don't think anybody will ever have a problem with that app. So maybe, like for example, Teachment app doesn't work on certain devices very well, right? For example, I have tried using Teachment on iPad, and I had a lot of problems. So in some devices it doesn't work well. So that's what I'm planning to do, right? So the sessions will be through YouTube like this one. I'll try to give more inputs, in the same session. That is number one. Number two, if I don't give any assignments, you can assume that you can do the practice from any one book of your choice, and there is a separate arrangement for competitive YouTube sessions. So those who are attending those sessions, they would perhaps be better if they do previous year's questions. For competitive, previous year's questions are the best. And finally, regarding the tests, yes, I'll definitely take tests. That is for sure. I will certainly take tests sometime in the middle or late February, perhaps middle February. Then in that case, you can expect that I'll make a classroom folder and assign the test to all of you. So that is what I'm planning to do. Okay, so okay, so the thing is that let's have a quick summary of the formulas. Not all the formulas, a few of them. Let's have a quick summary. So integration x to the power n is x to the power n plus 1 by n plus 1, provided n is not equal to minus 1. This is important. N should not be minus 1. Integration dx by x is log x. Please remember that you cannot write log x if x is negative or 0. You cannot do that. So x has to be positive. Integration e to the power x is e to the power x. Integration a to the power x is a to the power x by log a to the base e. Integration sin x is minus cos x. Integration cos x is sin x. Integration tan x is log sec x. Integration cot x is log sin x. Integration sec x is log sec x plus tan x, or log tan pi by 4 plus x by 2. Integration cosec x is log tan x by 2, or minus log cosec x plus cot x. Now when I say or, okay, so how relevant is that? I mean, how far is it important to remember the or version of the formula? Like you might say that, oh, I already have this one, so why is this or one, why is it needed? See, you must be aware that MCQ has become very important now, not only for competitive exams. Due to the pandemic, the forced changes in the board pattern and all, so MCQ has become unavoidable. So in an MCQ situation, they may give the answer in a particular form, right? And you should not be wondering that why is my answer not matching, etc. So you should know that there are two alternative answers, either this or. Similarly, this or, right? Now, these formulas 1, 2, 3, 4, these are considered basic. Sine, cos is basic. Okay, so 1, 2, 3, 4, 5, 6. These 6 are considered like absolutely basic. Why? Because you just need to understand that integration is the reverse of differentiation, and that will give you these 6. Now regarding the number 7, number 8, number 9 and number 10, these formulas 7, 8, 9, 10, in these formulas what happens is that these are not basic, they are considered to be derived by substitution. So number 7, number 8, number 9, number 10, these 4 formulas are considered to be derived by substitution. So for starters, let's identify 3 categories of integration in full class 12 syllabus. The entire class 12 integration can be categorized into 3 categories. Okay, one is substitution, one is partial fraction, and one is by parts. So the whole of the class 12 integration syllabus is broadly divided into these 3 categories: substitution, partial fraction and by parts. Now, as far as substitution is concerned, you have sums where a very obvious substitution is involved, and you may have some sums where these are involved: tan, cot, sec and cosec. So when a sum involves tan, cot, sec and cosec, so that is also considered substitution. But the difference is that over there you will use these directly as formulas, and in some other sums where algebraic substitution is involved, okay, is there any need to practice the proofs and derivations? Okay, no, there is no need. It's actually very ironic you ask this question, because I am immediately reminded of, excuse me, just one minute. So there's a student of mine, okay, and he used to say that, sir, I have a lot of problem in mugging up. Okay, maths is a subject where nobody even thinks of mugging up, right? But he used to say that I have a lot of problem mugging up. So for some reason he felt that integration formulas require mugging up. He felt like that. Okay, it is not true, but he felt like that. So what he did was he started proving every formula whenever it was required. Like whenever he was doing a sum, if he felt a particular formula was required, then he started proving that formula just for doing that sum, and obviously that wastes a lot of time, right? So I think it is each person unto himself or herself, whatever suits you. If you derive a formula and that gives you a satisfaction that you have derived it, and therefore it gives you a sense of legitimacy to use that formula, then go ahead, do the derivation. Like, yes, I can relate to your query because when I was a student, I also had this issue. Like there were formulas. I used to feel that if I don't know the derivation, then how can I use it? Psychologically, So the point is that you don't need to do any derivations practice because it will never ever come in any exam. It will certainly not come in competitive exams. It will not come in your board exam. It will not come in your school exam. In the scope of the syllabus, it is very clearly written that integration derivation will not come. When it is written very explicitly, uh, okay, okay, good. Mugging up is an art actually. Mugging up is not. I think it is much maligned. I think people unnecessarily talk negatively about mugging up. I think if you can mug up something and remember it and then use it at the right time, I think it is an art. So I am not against mugging up. I wouldn't do it, but I am not against it, and some of my best students have been very good at mugging up. So I would say that I am a passive supporter of mugging up. I don't actively support it, but so many good students of mine are good at it, have been good at it. So they have mugged up the whole book, for example. So I mean, I'm talking about subjects where you need to mug up, okay? So I don't think that's a bad idea at all. You can definitely mug up the formulas, not an issue. Like I said, mugging up should be a means to an end. Once you mug up the formula, you should be able to use it at the right time. I think that is more relevant. So coming back to the formulas, 1, 2, 3, 4, 5, 6, these are the basic formulas, and 1, 2, 3, 4, these are related to substitution. So what I'll do is that right now I'll not tell you any more formulas. Right now we'll just do a few questions to understand how substitution happens. We'll just do 1 or 2 questions, then we'll do the rest of the formulas. Okay, so let's have a look at some types of substitution. Like I said, in today's class, I think we should mix and match formulas, a few important sums, and maybe by way of these sums, I can give you some extra inputs also. And I'll consciously try not to do very, very easy sums. I don't think that will help anybody. So dx by x square 1 plus x to the power 4 raised to the power 3 by 4. Now in this sum, so you have to do this sum by substitution, and the substitution is not very obvious, but one thing you can do inside the bracket, if you take x to the power 4 common, so x to the power 4 to the power 3 by 4 is x cube, and remaining will be 1 by x to the power 4 plus 1. Okay, so this is a very good sum of substitution. This is, I will not say a very tough sum, but it's a slightly unusual, the substitution. So dx by x square into x cube 1 by x to the power 4 plus 1 3 by 4. So these two will become x to the power 5. Now you make a substitution, let 1 plus 1 by x to the power 4, let it be equal to y. So differentiate both sides. Okay, yeah. Now this is what happens in substitution. You make a substitution, you differentiate both sides and you replace dx with dy, right? So minus 4 by x to the power 5 dx is dy. So ultimately this will become y to the power minus 3 by 4 divided by minus 4 dy. And so that's it. And now you just have to integrate this. So y to the power minus 3 by 4, if you integrate it, it will become y to the power 1 by 4 by 1 by 4. And below will be a minus 4 also. So ultimately minus of 1 plus 1 by x to the power 4 all to the power 1 by 4. This is the answer, right? So minus of 1 plus 1 by x to the power 4 all to the power 1 by 4 is the answer. So this is an example of a sum where we are doing algebraic substitution. Yeah. Yes, actually, I think that's a very fair question you have asked, that how do we understand what substitution to do. So what I'm going to do now is I'm going to, because see, I cannot tell you all the substitution techniques in one meeting, it will be quite difficult. What I'll do is that today I'll tell you, rather I have just told you of one substitution technique which is not related with any special substitution formula. Let me clarify. So far in today's class I have told you 10 formulas, right? Out of that the first 6 are considered basic, so you leave those are not relevant to be discussed. I mean, they are relevant, but they are not relevant for discussion. The 7, 8, 9, 10 formulas are based on trigonometry. Now those formulas like 7, 8, 9, 10, those formulas you will have to use them when the situation arises that a sum after some steps becomes tan x or cot x or cosec x or sec x. Then you have to use formula number 7, 8, 9, 10. Now we will see those type of sums today, like the sums which involves formula number 7, 8, 9, 10. We will see. We haven't seen, we will see. Before that, a sum where you don't need anything except the basic. Basic means 1, 2, 3, 4, 5, 6. You need only the basic. So basic formula, you don't need anything special. You don't need 7, 8, 9, 10. Is there anything beyond 7, 8, 9, 10? Yes. But I don't want to cram it into one class. I don't think it will help anybody. Maybe we should have another class or maybe another 2 classes. Okay. So today we saw one sum. I am calling it as algebraic, as in there is nothing very special in this method. I have just taken this whole expression as y and I have replaced dx in terms of dy and I have got the answer. So this is one type of sum, right? So I'll take this whole expression as y, I'll replace dx in terms of dy and I'll do the sum. So this is one type of sum. So in this type of sum, I am not using anything beyond the first 6 basic formulas. Now your question is that in this also, how do we know that this substitution has to be done? Well, yes, I agree with you. It is practice, but I think it's also another thing. Somewhere, in your memory, if you can fit in one information that not only do you need to know the formulas, but also you should know what are the type of sums. So like I said, in today's meeting, we'll do 3 type of sums. One is the sum where you are not relying anything beyond the first 6 formulas. So that is one type. The next type is you are relying on 7, 8, 9, 10. And then there's a third type that also I'll show you. That is, you will have to take one algebraic expression but do it with a trigonometric substitution. So we will see these 3 types. So I think, if you ask my opinion, you can try this. I mean, I don't know whether this will help. You can actually sit with a book of your choice. Let's say your preferred book is R.S. Agarwal, for example. You can, or M.L. Agarwal, any book, okay. You just take a pencil and beside the sum you write down the type. You take a pencil in your hand, open the book, and beside every sum you just write down the type. And if you are not able to understand what type it is, then you can be sure that you probably need to do the sum to understand the type. It can happen. Like, see, we are not so gifted that just by looking at a sum immediately we can understand the type all the time. If you cannot understand the type just by looking at the sum, you'll probably have to do the sum in order to understand the type. That could happen. So after all this is completed, you can open your copy and start doing the sums. So yeah, you can give it a try. Like I said, substitution itself is a very big topic. See, I'll tell you, broadly speaking, integration has 3 categories. Like I said in the meeting earlier, I'm saying it again. There are 3 categories of integration. Number 1 is substitution. Substitution is the biggest. Okay, it is the biggest. Substitution alone will take a lot of time. So we may not be able to finish substitution today. Okay. Number 2 is called partial fraction. Partial fraction is a standalone topic. Like, every sum is a partial fraction sum, and there are about 5 varieties of them, but all of them are partial fraction. So partial fraction does not have lots of variety like substitution. So I would say partial fraction is much easier and it can be done much faster. Initially you have to get used to it. Third is by parts. Now see, in by parts what happens, there are I think 3 or 4 formulas and there are some techniques in by parts, but it is not difficult. So I would say the most time consuming is substitution. So probably in the fitness of things we should concentrate on substitution today. Then again, in substitution we may not be able to do everything. So in my opinion, suppose if I do like this, that today I'll tell you say 3 techniques of substitution, and then next day maybe I'll tell you like another 2 or 3 techniques, and then we can wind up substitution, and in that same meeting we can do partial fraction, something like that. So meanwhile, as you progress from one exercise to the other, you will be following the same progression as I am following. So when you sit with a pencil and a book and you do the thing which I suggested you to do, I think it will help. You can definitely give it a try. Okay, so okay, so next we come to the questions which are based on 7, 8, 9, 10. Those are also considered as substitution. So have a look at this sum. Integration sin x by sin x minus a so sin x minus a plus a by sin x minus a dx So sin x minus a cos x plus cos x minus a sin x by sin x minus a. So it is coming integration sin x minus a cos a plus cos x minus a sin a by sin x minus a dx. So integration cos a plus sin a into cot x minus a dx. So this is integration cos a, which is x cos a, and this is sin a into cot x minus a, which is sin a into log sin x minus a plus c. So this also is considered as a substitution sum. Why? Because it requires the use of formula 7, 8, 9, 10, and 7, 8, 9, 10 are considered substitution formulas. So this is one sum of that. By the way, this particular category is a very favorite in your board exam. It's a favorite. Like they normally will give question on this, right? So it may be a good idea for you to practice this one a little more. By the way, there's another reason why you should practice this one a little more, because trigonometry is something which people, it is at the back of their memory. They did it long back, so it's kind of faded into, it's not in your recent memory anymore, and therefore you should all the more practice this one nicely, okay, because it is totally dependent on trigonometry. Let's have a look at another sum. So dx by sin x minus alpha cos x minus beta. So you can write it like this: 1 by cos beta minus alpha into cos x minus alpha minus x minus beta by sin x minus alpha into cos x minus beta. Why are we doing it? Why are we doing all this? Why did we do this step over here? Why are we doing this step over here? I think you have probably got the hang that we are trying to take the sum in the direction of formula 7, 8, 9, 10. Mane, we want the sum to go in that direction. So to make the sum go in that direction, we are doing all these steps. So we are here deliberately writing x as x minus a plus a, because there is a x minus a in the denominator, and that is the reason. And here we are deliberately writing the the numerator denominator cos beta minus alpha like this, because we know that, in fact you will see just now. So 1 by cos beta minus alpha cot x minus alpha plus tan x minus beta. And now you have to use formula 7, 8, 9, 10. So 1 by cos beta minus alpha log sin x minus alpha by cos x minus beta plus c. This is the answer, right? So these are all examples of sums. These are all examples of sums based on formula number 7, 8, 9, 10. Now, to what extent are we using class 11 trigonometry? Like, are we making a very heavy usage of class 11 trigonometry, or is it very basic? Well, in this sum and in this sum, we are just using compound angle. The compound angle is considered very, very basic. So you cannot say that, this is class 11 trigonometry, okay, so then it's a little bit difficult or challenging. Nothing like that. We are just using compound angle. I mean, that can hardly be called difficult. But you may get a sum where you may have to use compound angle a little, you need to be a little more conversant with compound angle. I'll give you an example of that. Like, have a look at this sum. So integration of dx by a cos x plus b sin x. Integration of dx by a cos x plus b sin x. So 1 by root a square plus b square integration dx by a by root a square plus b square cos x plus b by root a square plus b square sin x. So let a by root a square plus b square equal to cos alpha, and b by root a square plus b square is sin alpha. So dx by cos x cos alpha plus sin x sin alpha. Yes, sorry Abhishekta, I had missed your previous query. So yes, that is completely unnecessary. I think it's a very relevant query. You see, what happens is that students are. I'm not saying all students, okay, but by and large, many students, they are used to spoon feeding. I mean, it's I don't know what other word to use, what other phrase to use. So what happens is that if you tell them how to do the sums, many times it's not enough. It's almost like you have to do a bit of hand holding and step by step tell them everything up to the last step. So the book writers, they have understood this, and for publicity of their book, for larger sales of their book, they cater to the larger audience, and they understand that there are some students, they don't just want to know the method, they want to see somebody showing them the entire sum all the time. So what these book writers do is they say that okay, there is an integration sum, and that sum you can split it into 2-3 integrations. So what they will do is I'll just complete this. So what these book writers do is that they will take a sum and they'll say that okay, this sum can be split into 2-3 sums and 2-3 portions, and then for each portion they will say write C1, then for the next portion write C2, then for the next portion write C3, and then in the end you add all of them and make it C1 plus C2 plus C3, and then you say that okay fine, it's not C1 plus C2 plus C3, it's actually C. So I think this is a extreme example of spoon feeding. I mean, I don't think students. Yeah. Yes. So like I said, that I think it's mostly related to the fact that the students. Ideally, I'll tell you what. Ideally, what a student should do is that see a few examples, either illustrated by the teacher in a class or given in the book, and then you should try the sum on your own. But unfortunately many students, they don't do that. They are they are totally dependent on solutions, and somebody has to show them every single step. And the book writers, unfortunately, they have understood this, and they have capitalized on it by showing the sum like that. So and it's a very relevant query, and I think it's a query which can come to the mind of any student. The answer is no, you should not write C1, C2, C3 at all. Just a C at the end of the sum will do, okay? And I have explained to you why. It's not actually due to any scientific reason, it is actually due to the fact that students are not able to take knowledge in a more I would say in the way they should be taking it, and that is also the reason why sometimes students end up making a very big mess of everything, things which are very simple, very basic. So they think that it's a whole lot of data, it's a whole lot of information, it's a lot of theory, and then how am I going to handle everything? So maybe as long as possible somebody should show me every single step, and then I am on my own, and then I'll see what to do. But I don't think that's the right way to do studies. And I think this is not relevant to everybody. Like I remember when I had done integration earlier, I remember in fact Abhishekta, you had submitted a lot of homework, and I remember that you had done every sum independently on your own. I mean, it was clear that you had not taken any kind of help or resorting to just blindly looking at solutions, which is not good at all. A lot of people do it. I would rather you do the sum on your own, make a silly mistake, right, rather than blindly copy some solution from somewhere. The problem is that students do it all the time, and the book writers have understood that. And when there is a supply, there will be a demand. So the book writers have catered to that demand by writing the solutions in a very programmed way. And that actually is increasing the problem, because when a student sees such a solution, then they are thinking that it's all very complicated. And that's how studies becomes very complicated. So I think in a nutshell, the answer is no, you don't have to write C1, C2. You just need to write a C at the end. That will do. Okay, there's no need to write C1 and C2. So basically, coming back to this sum, So 1 by root a square plus b square integration sec x minus alpha. Yeah, you're right. I just saw your comment again. You're absolutely right. It doesn't. It's not very productive. In fact, the student whose example I gave you earlier, there was a student of mine. For every integration sum, he used to first derive the formula and then do the sum. I think even that is not such a bad thing, because it gives him satisfaction. He is happier to derive the formula and then do the sum. That is also not so bad. What I'm trying to say is that nothing is bad except falling into the trap of being spoon fed, right? All of us have likes and dislikes as far as eating habits are concerned. So, suppose if somebody tries to spoon feed you and say that eat this, eat that, don't eat this, don't eat that, I mean, that's not a life which anybody is very happy to live. So, we like to have our own kind of food with our own hands. So, the same should apply to studies. The more you do things independently, make mistakes, okay, get wrong answers, make mistakes, answer is not matching, go through all that. I mean, everybody has to, right? So, that is how you will evolve as a student. I don't think blindly looking at solutions left, right, and center is not going to help anybody. So, basically, 1 by root a square plus b square dx by cos x minus alpha. Now, 1 by cos is sec. So what has happened is that we have used compound angle in a very interesting way. That first, I think you all can identify, this was there in that Trigo formulas big PDF of class 11, this technique was there. So the coefficients of cos and sine are a and b. So 1 by root a square plus b square dx by a by root a square plus b square cos x plus b by root a square plus b square sin x. So a by root a square plus b square is cos alpha, b by root a square plus b square is sin alpha. So 1 by root a square plus b square dx by cos x cos alpha plus sin x sin alpha. So dx by cos x minus alpha, that is sec x minus alpha dx. So what do we have left to do in this sum? I think we have almost done it. So 1 by root a square plus b square into sec x minus alpha. So 1 by root a square plus b square log tan pi by 4 plus x minus alpha by 2. This is the answer. 1 by root a square plus b square log tan pi by 4 plus. So this is, I deliberately wanted to show this sum to all of you, because this sum shows that how you can use compound angle, different techniques. So ultimately we are doing formula number 7, 8, 9, 10 only, but we can use this type of technique. So that is why I wanted, especially I was very keen on showing this sum. Okay. Yes, then we come to Trigo substitutions. Now this is again back to Trigo, but this time we'll use the basic formulas only, 1, 2, 3, 4, 5, 6. We will not be using 7, 8, 9, 10. But the sums involve some techniques, so I'll just tell you. Okay, now all of you see here. If you ever have root a square minus x square, you should put x equal to either a sine theta or a cos theta. If you have root x square minus a square, you should put x equal to a sec theta or a cosec theta. If you have root over x square plus a square, you should put x equal to a tan theta or a cot theta. If you have root over a square minus x square or a square plus x square, then you should put x square equal to a square cos 2 theta. Okay, so let's have a look at this sum. Integration cos twice cot inverse root 1 minus x by 1 plus x dx. So if you take x is cos 2 theta, then dx is minus 2 sin 2 theta d theta. So replace x is cos 2 theta everywhere, dx also replace. This is the next step. And and then it comes to this. So finally it is integration sine 4 theta, that is minus cos 4 theta by 4. Cos 4 theta according to class 11 formula is 2 cos square 2 theta minus 1, and this is the answer, minus x square by 2 plus c. So you will notice that in the previous step there was a minus 1/4 into minus 1, that will be a constant. So that constant and the c together I have considered it as the constant. So this is a question where you have to use trigo substitution. Now you will notice that whatever I have written here, when I am doing the sum, I am not actually using any of these. I am doing the sum, rather to some extent, yes, these two I am using. So this is an issue that just be aware that, okay, this sum, it is a trigo sum with algebra, like it's a trigo sum, but there is algebra inside it. So that means I'll have to make some substitution to convert it into fully trigo. So that substitution I understood, cos 2 theta, and then I did the sum, right? So this is trigo substitution. So trigo substitution is of two types. One is this. The other one, okay, suppose you have integration sine to the power px cos to the power 2n minus 1. So that means the power of cos is odd, then you have to put sin x equal to y. Suppose you have cos to the power px sine to the power 2n minus 1, that is the power of sine is odd, you have to put cos x equal to y. Suppose you have sine to the power px cos to the power qx, where p plus q is a negative even integer, you have to put tan x equal to z. So suppose you have integration root over cos cube x by sine to the power 11x. So let tan x equal to y. So sec square x dx is dy. So integration cos to the power 3 by 2x by sine to the power 11 by 2x into cos square x dy So you multiply above and below with cos square x. So cos to the power 11 by 2x by sin to the power 11 by 2x dy by cos square x. So integration sec square x by tan to the power 11 by 2. So integration 1 plus y square by y to the power 11 by 2. So y to the power minus 9 by 2 by minus 9 by 2 plus y to the power minus 5 by 2 by minus 5 by 2 plus c, and in both these places y you replace it with tan x. So this is the final answer, minus 2 by 9 tan x to the power minus 9 by 2 minus 2 by 5 tan x to the power minus 5 by 2 plus c. Okay, so this is the final answer, right? So today we have completed all the substitution techniques which are somehow related to trigo, and we also saw one substitution technique which was related to the basic formulas. Next day we will be doing substitution techniques which are entirely based on algebra, and if possible in that same class we will either start by parts or partial fractions after finishing substitution, right? So that is all for today, this meeting. Yeah, you're welcome. So I'll end the meeting and we'll continue again the next session. Thank you all. Bye all of you.